Today we are going to talk about a way to prove two triangles are congruent. So there are different postulates that we can prove. There are 4 altogether, I believe. Today we are going to talk about 2 of them. So the first one is called the side postulate. So what that means is that you have to have all 3 sides that are congruent. If you do, then you can say, okay, those triangles are congruent. So over here on the left, it says the 3 sides of one triangle are congruent. Remember, congruent just means equal to 3 sides of another triangle, then the triangles are congruent. So if we know that these 3 sides are congruent, now the order matters, just like we talked about yesterday. So let's say my A would be my number 1. So my A is in between the 1 tick mark and the 3 tick mark. So over here, the 1 tick mark and the 3 tick mark would be my D. And then my next one, let's say I go up the 1 tick mark to the B, so that would be my number 2. So up the 1 tick mark to the E would be my number 2. And then last, my C and my F would be my number 3. So if we know, now remember, order matters. So if my segments or my sides, so if segment AB, that was my 1 and 2, is congruent, is my 1 and 2 congruent on the left triangle to the right triangle? Yes, remember both these little tick mark things, those mean that they are congruent. They have to have the same number. So since segment AB has the 1 tick mark, segment DE has 1 tick mark, they are congruent to each other. So AB would be congruent to segment DE. And then let's go to the 2 tick mark side. So on the left triangle, that would be called segment BC. Now I started at 2 and I went to 3. So if I look at the right triangle and I start at 2 and go to 3, that would be called segment EF. And then my last one, I need to look at the 3 tick mark side. So that is segment CA. I started at 3 and I went to 1. So my 3 to 1 over here, or my 3 tick mark side, would be segment FD. So since I know that all 3 sides are congruent, then I would know that my 2 triangles are congruent. So triangle, when you're naming a triangle, you name it with that little symbol, just a small triangle symbol. Now, on the left side, if I were to name this triangle, triangle ABC, triangle ABC is congruent to, so what I'm drawing over here, what this is, it's just an equal sign with like a little squiggly on top. So triangle ABC is congruent to. Now remember, order matters. I cannot just go and say any kind of EDF, FDE, DEF. I can't say just any random letters. It has to go in the same order. So that's why I numbered these. So my ABC, I went 1, 2, 3. So now my second triangle, I have to go in the order 1, 2, 3. So my D was number 1, my E was number 2, and my F was number 3. So since I know that all 3 sides of my triangles are congruent, they're equal, then I would know that triangle ABC is congruent to triangle DEF. So let's look at this example problem. It says, given that segment LM is congruent to segment NP, so LM and NP, they are congruent because they both have 1 tick mark. And LP is congruent to NM, so LP right here is congruent, so it has 2 tick marks. To NM, it has 2 tick marks. It says, prove that triangle LMN is congruent to triangle NPL. Now, if you notice, they only give us 2 sides that are congruent. What about this third side here, the one that I have in green? So if you notice, both of our triangles, so let's say my green triangle here and my pink triangle, they both touch this side right here. So if they both use that side or they both touch that side, that's the exact same line. So therefore, this side right here, they would be congruent to each other because they are the exact same thing. So since I know that they are congruent, now if you look at your triangles, you have all three sides of these triangles that are congruent. So are my triangles congruent? Yes, they are. So triangle LMN is congruent to triangle NPL. Now it says we have to prove it, so we have to give a reason why. So the reason why, remember we just talked about up here, our postulates are side, side, side postulate. So we know that all three of these are congruent because all three sides are congruent. So since all three sides are congruent, it would be congruent by SSS, or I'm abbreviating, which is side, side, side. So I want you to look on your right side. So it says, given that segment BC is congruent to BF, so BC is this one tick mark, BF is the one tick mark. They're both congruent. CD is congruent to FD, so these both have two tick marks. Our triangle BCD congruent to triangle BFD, so you're trying to prove them. So you got to tell me, are they congruent and how? All right, the next one we are going to talk about is called the side angle side postulate. So just like the word says, you have one side congruent, you have one angle congruent, and then you have another side congruent. So this says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So what this means, this included angle, included just means in between. So our angle has to be in between our two sides. Think about this real quick. If you hold up your fingers like you're doing a peace sign. So here's your hand. I can't draw, I'm not an artist. But here's your peace sign right here, right? Your sides, so your two fingers right here, those are your sides. Right in between your fingers, so like in the web of your fingers right here, that is your angle. So if you're ever stuck somewhere and you're trying to figure out if it's side, angle, side, open up your two fingers, put them over your triangle, and if the sides touch your fingers and the angle is in between your fingers, then you have side, angle, side. But if not, then it is not side, angle, side. So our angle has to be included. Our angle has to be in between our two sides. So if you look at this diagram here, we have AB, which is congruent to DE because they both have one tick mark. So AB is congruent to segment DE. They both have one tick mark. We also know that AC is congruent to DF because they both have one tick mark, or two tick marks. Now, if you look, our angle is right in between our two sides. So angle A is congruent to angle D. Remember those arcs there mean that they are congruent. So therefore, since we have two sides that are congruent, we have an angle that is congruent, and our angle is included. That means our angle is in between our two sides. Then we would know that triangle ABC is congruent to triangle. Remember, order matters. So if I look at my diagram over here, I started at A, which had the angle. So my angle over here would be D. Then I went to B. I went up my one tick mark line. So up my one tick mark line on this side would be E, and then my last letter would be F. So we have side, 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 which means all three sides are congruent. And then we have side angle side, which means that two sides are congruent and one angle is congruent. That angle has to be included or in between. All right, let's look over here. It says, what other information do you need to prove that triangle DEF is congruent to triangle FGD by side angle side? So we want side angle side here. So we need two sides. You see our two S's, and we need an angle, which that angle has to be in between our two S's or in between our two sides. So if we look at this diagram, they only give us that EF is congruent to GD. What else can we mark here? So there's something that's not marked that we can mark. Remember up here, we looked at these example problems. Remember that shared side is always going to be congruent. So this side right here that's directly in the middle, we call that a shared side. It is always going to be congruent because it's the same exact line. So we can put two tick marks on that one. So now we have our two sides. So if I look SAS, I have a side, I have another side. What else do I need? An angle. So now we need to figure out what angle we need to show that these are congruent. So our name here, it was DEF. So I'm going to go number those. So D would be 1, E would be 2, and F would be 3. And then they went FGD. So now my F would be 1 here, my G would be 2, and my D would be 3. So if you notice, these are like mirrored over and flipped. So it's not exactly the way you picture it. So E and G would go together, but my D and D are not the same on both triangles. If you notice on this top triangle here, my blue triangle, my D is number 1. You notice on the bottom triangle, the green one, my D is number 3. So they're flipped over. So we need to figure out where our angle needs to be on both of these triangles here. So let's look at the top triangle. We have a side at the top here, and then we have a side down here. Remember, our angle has to be in between these two sides. So if you notice, I just traced it out in green. Those are basically my two fingers. So my angle would need to be right here, right where my X is, because if you notice, it's right in between my two sides. Then let's look at the bottom one. I'm going to do this one in pink. So my two sides, here's a side and here's a side. Those are congruent. So my angle would have to be right in between those two sides. It would have to be right here where I put my X. So my two X's are where my sides need, or my angles need to be. So now I need to name those angles. What are those angles called? Remember, when we name an angle, we name it with the angle symbol. And then since we have multiple letters for multiple things, I can't just say angle D and angle F. Remember, we have to name a letter with 3, or an angle with 3 letters, so we can know exactly which angle you're talking about. So let's name the green one. I have E, F, D. Remember, when I name an angle, I have to start on the outsides. I could have named this DFE, either or. But I named it EFD. Now the second one, my E was number 2. So now I got to start with number 2 down here. My number 2 is a G. And then I went to number 3, which was F. So number 3 on the bottom triangle would be D. And then I went to D, which was my number 1 on my green triangle. So my number 1 on my pink triangle would be F. So to prove these two triangles congruent by side angle side, I have to know that these two angles are congruent because I was missing an angle here. They only gave me two sides congruent. So now I want you to try the right side. It says, what other information do you need to prove triangle LEB is congruent to triangle BNL by side, angle, side? So let's look at this. They're giving you an angle. So here's my SAS. I need these three things. I need a side, an angle, and a side. They give me my angle here, so I don't need my A anymore. What else can I mark? Remember the shared side right here. They share a side, so I can mark one of my sides because they are congruent. So now I need an S here, but I need you to go figure out what S do I need or what side do I need. Remember, my angle has to be in the middle of my two sides. So I can't just choose a random side here. So if I use my red triangle, that would be what it looks like. And then if I have a blue triangle, it would look like this because my angle has to be in the middle. So I've marked them out for you. Figure out what the sides are called. Submit your answer and we'll go on to the next one. All right, this next one says, what other information do you need to prove that the two triangles are congruent by side, angle, side? So once again, we need side, angle, side. So let's look at our picture here. We have an angle. So L and M are congruent because you see those two tick marks or those two arcs. So I can cross out my A. I have a side because I have two arcs here. So what else am I left with? I'm left with a side. Now remember, our angle has to be in the middle of our two sides. So if I have one side here and one angle right here, I can't have this side on GT. So the one that I have in red here, it cannot be that one because my angle would not be in the middle. So a line or a segment that's in the middle that would create that angle right in the middle would be this one right here. So if you notice, if I create an angle here, if I draw out the lines, my angle's in the middle, this side would be congruent, and then this side would be congruent. So I would have to know that LG is congruent for that first triangle. Now I need to see what it's congruent to. Let's look at our second triangle. So I have a side here, I have my angle. Like I said before, it cannot be this side because my angle would not be in the middle. So it would have to be this side right here. So I went from L to G. So on this side, I would have to go from M to N. All right, this next one, it says, what other information do you need to prove that the two triangles below are congruent by SAS? If you notice, you have a side. Those two have two tick marks. You have an angle. You have another side that has one tick mark. Oh, maybe you don't need anything. Let's go look at it. So remember, where does your angle have to be? Your angle has to be right in the middle of your two sides. So this one is not already congruent by side, angle, side because our angle is not in the middle of our two sides. So figure out what angle you're going to need and then submit your answer and we'll go on. All right, it says in triangle HAT, the given angle is in between which two sides? So let's just draw a picture. What are we going to be drawing here? A triangle. So we have HAT, doesn't matter how you label it. It's all going to be the same. So it says angle H. So here's angle H. It's asking which two sides are in between or makes angle H in between them. So basically, which two sides does H touch? So H touches this side and H touches this side. Does H touch this side? No, it does not. So angle H is in between these two sides that I've traced out in black. So we're going to name them. We have side TH and we have side AH. What about angle T? So angle T is right here. Does angle T touch this side? Nope. T touches this side right here, and T touches this side right here. So it touches that, it is included, it is in between those two sides. So we need to name them now. So angle T touches TH, and T touches TA or AT, whichever direction you want to name them, you can. All right, it says, suppose you need to explain the term included angle to a friend over the phone. How can you make the meaning clear? So you're trying to tell me, what does included mean? So in your own words, what does included mean? All right, let's look at the last one. It says, would you use side, 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 or side angle side to prove the two triangles congruent? If there's not enough information to prove the triangles by side, 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 or side angle side, write not enough information. Explain your answer. Let's look at this first one. So remember, if we have side, 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 we need 3 sides. If we have side angle side, we need 2 sides and an angle, but our angle has to be in the middle of our 2 sides. So this one right here, the first one, we have a side. So those have 2 tick marks, both have 2. We have an angle, both have an angle. And we have another side. Is our angle in the middle of our 2 sides here? Yep. So what would we call this one? Side, 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 or side angle side? Yep, side angle side. So remember, side, side, side is 3 sides, not a side, 2 sides and an angle. Let's look at the next one. We have one side that has 1 tick mark. We have one angle that has 1 arc. We have another side that has 1 or 2 tick marks. What would this be? So a lot of you may be saying, oh, it's side, 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 angle side because we have 2 sides and an angle. But look at this second triangle here. So this first triangle, we have a side, an angle, and a side. That is included. What about this second one? Is our angle included? No, remember, if our angle is included, it would have to be right here. It would have to be in between our 2 sides, but our angle is not in between them. So this is nothing, just not enough info. And then the last one, let's see what it is. So we have a side, a side, a side, and a side, a side, a side. What do we call this one? We have 3 sides. Side, side, side. That is correct. All right, I want you to try the last one. Submit your answer on all 3 of those, and we'll see you tomorrow.